Hey everyone, welcome back. So in the last video we would discuss about some scalability and all, but उससे पहले मुझे लगा कि थोड़ा सा distributed system and all how AWS Azure is actually on in the base level ये पता होना चाहिए. So what is at the end? It's some distributed systems. So distributed जानने से पहले let's start with some important thing that we have to know. So सबसे पहले क्या था? सबसे पहले centralized system थे. So centralized system क्या होते थे कि they are like a single server with basically a very big server. Suppose we are thinking about some Amazon level and have a lot of requests are coming on a single server, but it's very hard even for a single server to handle these 1 million because suppose you have a good machine, you have let's raw समझ लो कुछ नहीं पता तो suppose you have a good machine of 1 TB of SSD and have good let's take 512 GB of RAM. So it is capable or good server? It's not. It's worst. Actually, it's not even very good server to handle a good traffic. So suppose if we grow more like one 1 TB to of SSD to 1 TB of RAM and 4 vCPUs, then eventually it will not be good to handle because it have only one server and it have to all the computation running on only on one server. So it is a kind of centralized thing. Okay, so eventually it's not good. It's good for a lot traffic. You can create your own laptop as a server for free use, and but for a lot traffic it will work, but for large traffic it will never work. So how it came to distributed server, or can we create our own server? Like what is the prerequisite to create our own distributed it's not server, it's a distributed system. Basically it's a centralized system and it's a distributed system. So this is a centralized system or a server, and it have a multiple calls coming from different clients according to different region, and it's very hard to scale it up eventually because suppose let's do a rough call, something bad happened to this, like who knows what will happen. So something bad happened to this particular system or server, all calls now become crashed, 404 not found and all. Okay, or so this, and even suppose you have to scale it up, suppose you have a 512 GB, now you want to 1 TB, so there is a downtime you need, like we have a system upgrade and the services will down from this to this time, and you might know when the services will restart. So this is the case, this is the centralized systems, and then we go to the distributed system. In the distributed system what we have different computers which are term as node, and they are connected to each other, and basically they are connected to each other, they are talking to each other, and they are transferring data and all to each other. So basically it's not a now a one computer, it's a different computers. Like suppose it's a 1 TB SSD, 1 TB SSD, 1 TB SSD, 1 TB SSD, 4 TB SSD, like one have 4 vCPUs, so I have 64 vCPUs, and all these are connected. And even if one system is down, okay, the all three is working, and now the connection between three and the particular thing they are doing is divided into three. But in the case of distributed system, they are doing only a task. Means पहले क्या हो रहा था कि there is a machine which is doing a task. Now there is a simple a task which is doing by all these four machines. So this is a big game that is happening here. Suppose we have a, let's take an example of Google. Okay, so it's a case study. I am not sure it's actual case study or what. If I Google, it have some index query is running, and suppose it have 1 TB, well, not 1 TB, 10 TB of data, and in that 10 TB of data, uh, you have to find the top trend site or top hit site, or you have to query each time you search. It's very hard to do it every time, to traverse a lot of time, traverse a lot of data. So for a single machine, it's a very tough job. So at the end, you have to go to distributed system. You have to okay, multiple machine connected to each other, and they are talking either via RPC calls, and yeah. So this is distributed system. But in the case of distributed system, there is some bottleneck also. Like if we have a only single DB, that if we have a distributed system, but you have a only single DB, then sometime it cause a bottleneck for us, because maybe the particular it can block the IO threads. But it's the other case. We can talk about it later on how to we can scale it also. But this is the distributed system. When we have a R task, but we have a different computers, different machine working on a single task. This is distributed system. Okay, you know now what is single and centralized and distributed system. Now we go to what we need. So सबसे पहले डिस्ट्रीब्यूटेड सिस्टम अगर हम बना रहे हैं तो हमें क्या होना चाहिए? सबसे पहले हमारे जो डिस्ट्रीब्यूटेड सिस्टम है वो मतलब मीन्स ऑल द नोड मस्ट कनेक्टेड टू ईच अदर। ऐसा नहीं है कि सम कुछ और कर रही है, सम कुछ और कर रही है, रिजल्ट कुछ और आ रहा है। So they are concurrently, they know what they are doing, they are properly connected to each other, and they have to do the same task each. And the other part is scalability. Suppose you have to add some more nodes to do to scale your system up. So it's not, there is no downtime. The best part in, if you are creating a distributed system, there is no downtime, a very small downtime. Okay, suppose you have a very big thing is coming and you have to restart all your servers or machines, then it's time, because you can give a simple or small downtime. So scalability, the main is fault tolerance. So, in the case of distributed system, suppose you create a room. In that room, are all computers are connected to each other, but something is off and the power backup is down. So you are not available, you are at downtime. So it's better, like Amazon and Google and Facebook and every big company have data center in different reasons. So suppose one data center is crashed because you can say some like earthquake, storms, or anything, we don't know what will happen. So anything happen and it will crash eventually. You do not rely on only one data center, you have multiple data center that is currently working and have a replicate of, you have a replica data. So if the replication is important, each time your node is working, for a single node or single thing that is happening, each node must have replica of what is happening. So if one node is shut it down, because at the end they are machines, they have any hardware malfunction or anything happen, the node shut down, so it doesn't stop your workflow or anything working. The other node have replica of that. So eventually this work should have to be done. And the other thing, recoverability, means you can recover your data and all. It's a sample. And the SSD and SSD thing, because each time the machine is running, it have a logs that generated each moment. So you have that in your SSD, because at the end RAM is now volatile memory. So at the end, if your server crashed or server's down, you don't have any log, and eventually it will crash. So you have to know all these fault tolerance thing before you creating your own distributed system. And the transparency nothing, is just you have to hide the complexity from the user, everything. You have to just give you a button. Like in the case of render, what we have, render shows you all this, that he created a system with AWS and all that. It's a wrapper of AWS, but at the end, it what it did, it suppose render is a AWS. Okay, for a time being, it's not, I know. So what it shows you all this, he created a server, he created a room, he created a lot of server, it have created a yada yada yada. So we don't want this. So abstract it, hide the complexity from the user, and give them, okay, you can use this thing, you can import your code or anything here, and we can import the server and everything is live. So that's the thing. Behind the scene, it's a very tremendous thing are happening. We can do the practical also, if we can do. Okay, so for a distributed system, what we need a simple node server, which is computer at the end. Computer machines are connected each other. We have a network calls. There are some two kind of network calls with a local call and remote calls. Local call is like your HTTP, HTTPS, and all that. And in the call remote call, we have RPC and gRPCs that are connected. That basically when in the locals, when the computer communicate with each other, they are do via local calls. Okay, and in the case of middlewares, simple. It's a software calls, RPC calls. The client is particular person that is interacting with the system. So the node is doing some job and returning to the clients by HTTP and HTTPS. So these are the some distributed stuff. And it is, you can say, it is a client server architecture with yeah, it's a simple client server architecture. Okay, in the case of architecture, we can understand some architecture. Okay, so these are the some simple architecture, client server architecture, and multi-tier architecture. These are the basic ones you can study anyhow. I want to explain you P2P. So P2P architecture is like very good. Okay, I can't. Okay. I will explain P2P in the brief now, if we are there. So in the case of P2P, what have suppose we have our server which is transmitting the data to thousand of peoples, okay, and it have 10 GB of data that is transmitting thousands of people at regular interval, like it's a CCTV data, and at each 10 minute it refreshed and it transfer data to thousands people each 10 minutes. So if you calculate it, it's quite heavy to do each 10-minute data transferring, and each thousand people, which thousand is very less. We can increase it later, but let's for now it's like thousand people. So thousand people is doing all the calls and every 10 minutes. So it's quite heavy operation to do over a single server. Eventually, let's not tell like 10 million people for each 10-minute and with 10 GB of data and all the things. So it's take time to do. Main thing, it's not randomness. It take time. Like suppose for now you have a server which is quite slow, so you get 10 minutes for a single video to be downloaded, which is eventually take time. So what we can do, we can do like we can is you scaling also, but it's not good at the end. If you study about it, it's not good. Even sharding is not good here. We have to do at the end P2P. So what is P2P? P2P is like when we have a data, we divide all the data into small chunks and distribute over the network like BitTorrent did. And suppose you have a data of 1 GB, you can divide it into multiple small chunks, suppose of 1 MB 1 MB, and divide all over the network. So what we have to do, when we are downloading the data, we are uploading the data as well. So basically we are not connected to any network now, we are connected to all the in our environment and just transmitting the data from our environment. Simple. So this is P2P call. You can say each node, now each, there is no single machine. There are the servers all over the network and they are connected to each other and we are doing the things. Okay, so in the case of BitTorrent, BitTorrent is a P2P. Yeah. So BitTorrent is a decentralized file sharing protocol, and so the BitTorrent. So you can study about P2P, as P2P is a good topic to understand. And other part, if you go with microservices, I can explain the microservices. In the case of microservices, you is service, it's a thing I can't remember, but it's like a some service thing, service architecture, where which is a same of microservice, but you have to understand that before understanding microservice. Microservice is nothing. Suppose you have a Node.js code. Okay, let I explain that also if it is came here. So suppose you have a Node.js code. Okay, and even students are confused in that too. So suppose you have a Node.js code and you have a lot of API. You have a lot of API. And what if something happened with this API where you don't added your null pointer and all that. Something happened with this API, and something you didn't configure your AWS machine or servers or anything else. So the server doesn't restart even it is cut it down. So what is done? All your API fails suddenly. Suppose you have a 62 functional API that is working, it's failed now. So it is a monolith architecture. Basically, one fail, all fail. Okay. And even it's slow also. In the case of microservice, your each Node.js API is a different service. Okay. And installed not. It's running on different servers eventually. So if it's one fail, all are working fine. And basically they are communicating with each other also. Okay, so this is a microservice, but it's not whole microservice. Microservice, if you gonna, I will deep dive later. But this is a some basic overview of microservice from eagle point of view. So that's all. That's all the distributed system. So basically, it's a video on distributed system. How what is AWS at the end? It's AWS, Azure, GCP. It's all distributed system, and they give us these things, which is impossible to give by any. It's not impossible. We can create that. We can build that, but it's quite tough to create a particular data center and do all the thing, because at the end, suppose you go on a Flipkart and you order up iPhone 16, you paid the bill, and at the end moment Flipkart lost your data, so nothing, we can't track that. Eventually we can track via your payment. Yeah, we can track it via payment. Okay, I will study about it. Okay, thanks for watching. Bye bye.